Hello, welcome to this course. I'm Ephraim and I'll be taking you through this short course, and the course title is Orthographic Projection, just an introduction to the basics. So the expected learning outcomes from this course is you should be able to differentiate between various views in orthographic projections, and you should also be able to draw the views accurately. You should read and interpret orthographic drawings and display them between different views and the 3D object. Then you should also be able to apply orthographic projection and techniques to solve real-world problems. So before we begin this course, there is just a brief note here to the learner, and just what it's generally saying is that the figures we are going to use are colored, but it is not expected of you to color or shade your drawings unless advised otherwise by your lecturer or teacher. So let's just dive into it. Orthographic projection is a method of representing three-dimensional objects into two-dimensional drawings, and basically we mostly use three two-dimensional geometric forms or drawings to represent the orthographic projection. So basically what we are saying is, if you are to be given a figure like this one here, and you are to stand directly at, let's say, at point 4, then whatever you will be able to view, you will be only able to see the yellow faces, the faces that are colored yellow. If you are at view number 4, you will only be able to see these yellow faces, and if you are to be directly at the view number 3, then you will only be able to see the red faces, this and this. And if you are, for example, to be at the top view, you'll be able to see the green faces, this and this. And if you are to be at the point number 5, then you'll be able to see although it cannot be clearly shown here for point 2 and 5, we'll be able to demonstrate that shortly. So the next slide will show us how the views will be represented, and as you can see, this is for view 1, view 2, 3, 4 and 5 as it follows. So I'll just be able to show you that shortly in Inventor. First, let's discuss orthographic projection again. So there are two separate methods of representing orthographic projection, and that's the first angle and the third angle orthographic projection. So the third angle orthographic projection is becoming more popular in the world and might become the only accepted system in drawing. This course is being taught in Kenya currently, so in Kenya we use both methods, and the building industry in Kenya mostly uses the first angle orthographic projection, while the other trades of engineering prefer the third angle orthographic projection. Consequently, the learner should be able to be conversant with both methods, as these are both examinable. So we are talking about first angle and third angle projection. Where do these names come from? And it can be noted that they are derived from mathematics, and a circle is divided into 4 quadrants, where the first angle orthographic, the object or model being viewed, is placed in the first quadrant, while for third angle orthographic projection, the object is placed in the third angle, placed in the third the object is placed in the third quadrant. So we will not be using the second and the fourth. Not be using the second and the fourth quadrants, because these complicate the drawing views, where one view is placed on top of the another, and this complicates instead of making the viewing much simpler. So to demonstrate orthographic projection, let's consider this cube, just like the earlier model that we saw. So if you were to see these planes are our planes, these are our planes, and our plane, as we will define later, is a perfectly flat surface. So the face that you see here is projected on this plane, and the face that you'll see here is projected on this plane and this plane. So if you were to view the cube from the top, you will see this sort of blue face. And if you were to see the cube from this side, you'll be able to see the red face, as you can see here, will be projected on this plane. So here is the view of what we are talking about. This is how you view it from the top, this from the end and the front. As you can see, this is our top, this is our end side, and this is our front side. So orthographic projection is important not just because several views of the same object can be drawn, but because the views are linked together. So to obtain the views, the 3D object is imagined to be suspended between planes, just as we have demonstrated here, between planes like this, and then where we can say that the plane is a perfectly flat surface. So the views that we'll be able to use, as we have discussed in the previous slide, will be the top, the end, and the front. So that is the front view, the side view. The end and the side view can also be called, the end and the side view are the same thing. Then there are also sectional views and auxiliary views, but auxiliary views are used in special situations. For example, in surface development is where you will do mostly auxiliary views. Sectional views, you will use them, but they are mostly used in assembly or working drawings. So assembly and working drawings are just the same thing. So one basic principle that you should capture is that the front elevation displays the height and length of the objects. The end elevation usually displays the width and the height, while the plan elevation will display the length and the width of the objects. The views, as we have said, can also be referred to as elevations. So orthographic projection also has another advantage where it overcomes the difficulty of drawing circles and curves on 3D objects due to its complexity in drawing any number of views of the same object. So as we have discussed, you can use more than the 3 basic views. You can also add the other views depending on the instruction. So the forms of orthographic projection, as we have discussed earlier, will be first angle orthographic projection and third angle orthographic projection. Then you should also note that the actual views drawn in orthographic projection are exactly the same. The only difference being the orientation and the position of the views. That is what differentiates them between being a first angle and a third angle, but basically the views are all the same. So let's begin with third angle orthographic projection.